Graphing quadratic functions. So this is going to be looking at graphing quadratic functions without a calculator. So one way to do this is to create a function table. And you can create a function table by picking x and y values, or x values, to plug in and find out what the y values will be. So let's plug in -1, 0, 1, 2, 3, 4. So I'll show a few points. Plugging in 0 is easy. 0 plus 3. Plugging in 1 is pretty easy. -3 plus 3 is 0 plus 4. Plugging in -1, this will be -3. Minus 4 becomes -7. Plus 3 is -4. So that's enough data points to start. I'm just going to plug in one more number just to show how this works. So I'm going to plug in 4. So -3 times 4 squared plus 4 times 4 plus 3. 16 times -3 is -48 plus 16 plus 3. That becomes -32 plus 3, or -29. Now, there's another way we can find this, which is to say, okay, we added 7, and then we added 1. So in our third difference level, what that means is going from adding 7 to adding 1 means the second difference is going to be subtracting 6. So the slopes are going to be going down by 6. So the next slope will be down 5, then we'll be going down 11, and then we'll be going down 17. So 4 minus 5 gives us -1. -1 minus 11 gives us -12. And hey, it works out. -12 minus 17 gives us -29. So that's one way to do it. But the faster way is to graph the vertex, because you have to have the vertex, and find a second point. Usually, pick an intercept, either x or y intercept. You graph the second point and its reflection over the axis of symmetry, and that's enough to graph our function. So the vertex, we'll use x equals -b over 2a. B is 3. A is 2. So the x-coordinate of the vertex is -3/4. We can now put a line at -3/4 at x equals -3/4. All right, now the y-coordinate, we'll plug in -3/4 to find out what the y-coordinate is. So this you could do in a calculator. I'm not using my calculator right now, so 9 times 4 is, let's see, 9 times 4 is, no, 9 times 2 is 18 sixteenths. This is -9/4, and this is -5. We need to get these all to have the same denominator, so this one could simplify to, let's see, 9/8, meaning we need to convert these into eighths. 5 times 8 is 40. 9 times 2 is 18. So now when we subtract, we'll get -9, -49/8, which is going to be -6 and an eighth. So our vertex is -3/4, comma, -6 and an eighth. Go down 1, 2, 3, 4, 5, 6 and an eighth. Our y-intercept is pretty easy. It's 0, -5. 1, 2, 3, 4, 5. We can also reflect that. That's 3/4 away from the axis, so we can go another 3/4 left of the axis. And now that's enough to start a graph. It's not going to be perfect, but here's an approximation of what that graph is going to look like. The more detail you want, the more points you're going to pick before plugging in. But this is the minimum to graph the vertex and one other point reflected across the axis. All right, so this is the same one that we did before. Negative b over 2a. Negative 4 over 2 times 3, negative 3, is negative 4 over negative 6, or 2/3. So we can draw our line, our axis of symmetry, at positive 2/3. Now we're going to plug in 2/3 in here. So y equals negative 3 times 2/3 squared plus 4 times 2/3 plus 3. This is going to be negative 4/3 plus 8/3 plus 9/3. So that's 17 minus 4 is 13/3, which is the same thing as 4 and a third. So our vertex is 2/3, comma 4 and a third. So let's go up to 4 and a third. It's going to be about there. Our y-intercept is 3, and we can reflect that over. This was 2/3 away, so we go another 2/3 away. And now that's enough to start graphing our parabola. And that gives us a rough idea of what this will look like. Oh, let's just check based off of our table. We had negative 1 comma negative 4. Negative 1 comma negative 4. So we were a little off there. 0 comma 3 was right. 1 comma 4. 1 comma 4. Yeah, that was right. And 2 comma negative 1. 2 comma negative 1. Yeah, that was about right. And there was one more point that fit on the graph. No, there wasn't. 3 comma negative 12 was off the graph. So, next one, vertex. We have 5 and negative 3 are the roots. Ooh, so that's 5 comma 0 and negative 3 comma 0 are our roots. Let's go to 5 comma 0 and negative 3 comma 0. So for finding the axis of symmetry, it's going to be halfway between 5 and negative 3. So that's 2 over 2, which is 1. And you'll also see that when we graph the line, there is our axis of symmetry. Now we can plug in 1 as our x-coordinate, negative 4 times 4 gives us negative 16, and that's super far down. So let's actually let's say that this is going by fives. This is 5, 10, 15, 20. So now this will be 16. And now we can use that, and we have an approximation of our graph. Next. Here, vertex is easy. We have the vertex given to us. 2 comma 5 is our vertex. 1, 2. 1, 2, 3, 4, 5. Yay. That makes our lives easy. It also gives us the axis of symmetry, because the vertex always passes through or is on the axis of symmetry. So now we just need to pick another point. Let's see, what point will be easiest to find? We could plug in a number for x or y. Let's plug in 1. 1 seems like an easy number to plug in. 4 times 1 minus 2 squared plus 5. 4 times negative 1 squared plus 5. 4 times 1 plus 5 is 9. So that's going to be our point. Reflect that across the axis. That gives us another point. So there is our parabola. I believe that's it. So you're always allowed to use a graphing calculator, but this is the process that is the fastest for getting a rough sketch. Make the vertex and find a second point to reflect across the axis.